The U.S. Department of Energy reported that more than 59% of homes were heated by natural gas. A random sample of 310 homes in Oregon found that 209 were heated by natural gas. Test the claim using a 1% level of significance. So what type of test will be used in this problem? If we identify the claim, that will help us determine what type of test to use. So let's parse that out first. So we have the Department of Energy reporting, so claiming, that more than 59% of homes were heated by natural gas. So that means our claim looks like this is a percentage, so we'll use P for the proportion or percentage of homes, is more than 59%, so greater than 0.59. So we're testing a percentage, which means this is a test for a proportion. And eventually, when we go to use the calculator, we're going to use the function 1propztest. And that is using the normal distribution for its calculations. This is effectively using binomial distributions in this test here, but there's something that tells us that we can substitute normal distributions for binomial probabilities, provided that n times p and n times q are both greater than 5. So if we identify these values, so n is our sample size, and we have 310 in our sample. P is the probability that we just got from our claim, so 0.59, and q is 1 minus that, so 1 minus 0.59 is 0.41. And as long as both of these values are larger than 5, then it suffices to use 1propztest. So 310 times 0.59 and 310 times 0.41, those are both bigger than 5, so we're set to go. Entering the null and alternative hypotheses, what we need to do is take our claim, which was P is greater than 0.59. So there's no statement of equality there. That means that my claim is going in the alternative hypothesis. I'll go ahead and mark that that was that. The complement of the claim, less than or equal to 0.59, is effectively what should go here in the null, but more often textbooks are starting to use only an equal sign in the null hypothesis, so that's what we'll adopt here. Now, is the original claim located in the null or alternative? Well, it was in the alternative. And what is the critical value for the given statistics, and what is the p-value for the test? That's the information that we get from 1propztest in the calculator. So if I hit stat and slide over to tests, then 1propztest is down there. Just look for it. P0, that is the value that we use in the null hypothesis. X is the number of items that favor our event in the sample. And scrolling back up, that is, let's see, 209. So we have a sample of 310 homes. And of those 310, 209 were heated by natural gas. And the alternative hypothesis tells us what type of test we would be using. And since this is greater than symbol, it's a right-tailed test, but just match the symbol that's in the alternative. Then we calculate, and it will output the statistics. So this is actually a better term, we'll say test statistic, rather than a critical value. And that is 3.01 in this case. So 3.01. And the p-value is right below it, so 0.0013. Okay, what is the decision based on the given statistics? Well, if we take our p-value, which is 0.13%, change it to a percent, it's just easier to make the comparison. And we compare that to our level of significance, which I'm just going to scroll back up and find that. So that's 1%. All right, so the p-value is, oh, sorry, it's not greater. That's why we change it to a percentage, because sometimes it's easy to scroll over leading zeros and where the decimal is and just kind of focus on whole numbers. But 0.13 is certainly smaller than 1. So p-value is less than alpha. So what we do is we reject the null hypothesis, because the rule is if p is low, the null must go. So we reject the null hypothesis, and our interpretation is using a 1% level of significance. There, we're either going to put is or is not in this blank, and we choose the stronger of language because we rejected the null hypothesis, which is the stronger of the two results we can have. So if we had failed to reject the null hypothesis, we would put there is not. All right, so next we need to decide if we're supporting or rejecting the claim. And the easiest thing to do there is just, if our claim is in the alternative hypothesis, then we're trying to support it. If it had been in the null hypothesis, then we would be trying to reject it. But if you want a little bit more idea as to how that logic works, we rejected the null hypothesis in the decision. So if we reject it, we're basically saying that it's a false statement. And that leaves the complement of that to be a true statement. So that means the claim then is true, because that's where the claim is located in the alternative. So we picked this stronger language is here. And if we're stating that this claim is true, so then we should say there is sufficient evidence to support the claim. Because if we'd said reject, that would mean that we're saying it's false. So that's how the logic works out there. But certainly you can just memorize the way of deciding those blanks, and that's fine as well.